Hello, everyone, and welcome to SciLine's media briefing on the total solar eclipse. It's going to sweep across the United States on April 8th. Our goal today is to enrich your understanding of this cosmic event and your excitement about it, and to help you share that understanding and excitement with your audiences. I'm SciLine's director, Rick Weiss, and for those of you who are not familiar with SciLine, we are a philanthropically funded, editorially independent, totally free service for reporters based at the nonprofit American Association for the Advancement of Science. Our mission is pretty straightforward. It's to make it as easy as possible for you as reporters to include validated scientific information in your stories, whether those stories are about a science topic like today, or are about other things going on in your locality or community where some scientific data and research-backed evidence could help strengthen that story. And in our perspective, there's almost no story that can't be made better by a little bit of scientific data. Among other things, we have a free matching service that allows you to come to us on deadline, tell us what kind of story you're working on, and we will find you an expert who can help strengthen that story for you and get you connected to them in time for you to include them in your story. Just go to our website, click on I Need an Expert, and we'll be right with you. A couple of quick logistical details before we start. We've got 3 panelists today who are each going to speak for up to 7 minutes or so each, and then we'll open it up for Q&A. To enter a question, just go down to the bottom of your Zoom screen to that Q&A icon, hover over it and click on it, put in your name, your news outlet name, and your question. And if you want to direct that question to one of our speakers in particular, go ahead and note that as well. A full video of this briefing will be up by the end of the day today, and a transcript will follow a day or so after that. If you need raw footage even faster than the end of the day today, just get in touch with us through that Q&A box, and we will get you something as soon as this session is over, about an hour from now. You can also use the Q&A box to let us know about technical difficulties you may be having. Okay, I'm not going to take the time to do full, long introductions of our speakers today. Their bios are on the SciLine website, sciline.org. But I'll tell you that we will hear first from Dr. Shannon Schmoll, director of the Abrams Planetarium at Michigan State University. And she's going to give us a short overview of how solar eclipses occur, what determines the path of totality, what scientists can learn from solar eclipses, and she's going to share some practical tips for how you can best and most safely watch the eclipse. Next, we're going to hear from Dr. Andrew Farnsworth, who's a visiting scientist at the Center for Avian Population Studies at the Cornell Lab of Ornithology. And he's going to speak about the effects of solar eclipses on animals, a special focus in particular on birds. And third, we're going to hear from Dr. Paul Piff, who is an associate professor of psychological science at UC Irvine. And he's going to focus on the social effects of awe-inspiring events like solar eclipses, those effects on people, and how events like this can shake up our sense of scale and change our perspectives on things and even influence our behavior. So let's get started, and over to you, Dr. Schmoll.
All right, thank you. I will share my screen. So I am going to talk a little bit about an overview of solar eclipses and why we have them. And so we're going to jump right into it. So part of the reason why we don't have solar eclipses all the time or every single month is because the moon's orbit around the Earth is tilted by about 5 degrees. This is not to scale, but it helps illustrate the point here. And so as the Earth-Moon system orbits around the sun, there will be some points where the moon is lined up with the Earth's orbit and the plane of Earth's orbit. So most of the time, because of that tilt, if you say, look at the example on the the right-hand side, because of that tilt, the moon's shadow that it casts behind it when it goes in between the Earth and the sun misses the Earth. It's either it's above or below the Earth, and so we don't really see an eclipse. But if we end up in a different orientation where that new moon, where the moon again is in between the Earth and the sun, and it's crossing into the plane of the Earth's orbit, so into the same layer as Earth's orbit, we will end up having the moon's shadow cast onto the Earth. And so when we're in this orientation, we have about a 34-day window, which we call the eclipse season, where as long as we have a new moon in that 34-day window, we will end up with a solar eclipse. And since the moon takes less than 34 days to go around the Earth, typically we end up with about 2 a year. And so this time we have one. There we go. This is sort of a diagram from the side view showing how the sun's rays will pass by the moon and how that shadow will be cast onto the Earth. So on the bottom right there, I have a couple of images. It's just me shining a bright light on a ball in my office. And you can see that there's the darker inner part of the shadow, which we call the umbra. And then surrounding that is a lighter shadow called the penumbra. So that is in the second picture circled in bluish teal is the umbra, and then in yellow is the penumbra. And so as the moon goes around in its orbit and the Earth is rotating, the shadow of the moon being cast on the Earth will move across the Earth. And so if you are within that path of the umbra, that dark part of the shadow, you will see a total solar eclipse. And we call that the path of totality. Whereas if you are in the path of the penumbra, the lighter part of the shadow, you will see a partial solar eclipse. So the moon will go in front of the sun, but it will never completely cover it like we have in the path of totality. All right, so this is the path of totality for the eclipse that is occurring on April 8th. And so it is going across North America. It will first hit land, the shadow will first hit land in Mazatlan in Mexico, and then go from Texas to Maine, and then end off the coast of Newfoundland. So we're going from Mexico through the United States and then parts of Canada as well that will be able to see the total solar eclipse. The path is about 100 miles wide or so. So as long as you are within those 2 blue lines that you see on this diagram here on this map, you will see it as a total solar eclipse. And then outside of that, you will see a partial, and the farther away you are, the less percentage of the sun will be covered by the moon. And the closer you are to the center line, the middle red line here, the longer the totality will last for you. So the longest point is a city in Mexico, which is about 4 minutes and 28 seconds. And anywhere along that path, you're looking at about 1 minute to 4.5 minutes or so for the path of totality. A really useful website is timeanddate.com. They have a really nice interactive map that will tell you the exact information, start time, maximum eclipse time, percentage of eclipse, and so on for a given location. So that's a really nice resource. All right, so one of the big things is safety. We know we don't ever want to look directly at the sun. It will harm our eyes and can cause permanent damage. So to look at this, you need to use either eclipse glasses or some sort of eclipse viewers, where you put those in front of your eyes when you go and look at the sun. And you want to make sure that they have the proper certification on them from the ISO, saying 12312-2 is the code, and you can also look that up at places like NASA. So it should have that, but also double check them. There are fraudulent ones out there. So make sure that when you look at the sky, look on a sunny day or with a few clouds, but look away from the sun. You should not see anything at all through those glasses. The only thing that you should see is the sun through them. Double check them for scratches and holes as well. You can also create indirect viewers that will project an image of the sun. Something with relatively small holes in it will, if you hold it out, it will project an image of the sun onto the ground. So a Ritz cracker is good enough for this. Go around your house, find things that have holes in it, a colander, a spoon, take a card and punch some holes in it. Those will all be great to project an image of the sun. Also, what else you can expect, the good, the bad, and the beautiful, I guess, here. So the good is you will get to see totality. So if you are in the path of totality, you will be able to see the outermost part of the sun's atmosphere that we call the corona. It will get darker around you. There's 360 degrees of sunset. Some of the brighter planets and stars will be visible. Even if you are not in the path of totality, you will feel that it gets a little eerie and strange, and temperatures will change. And it is a really breathtaking sight. On the not so good part, do be prepared for traffic. There is going to be a lot of people who want to see this. And so I ended up stuck in traffic for about 13 and a half hours during the 2017 eclipse. So just be prepared for that. But really, this is a wonderful, beautiful sight in order to see that corona. And so if you can go to totality and are able to, we highly encourage it. And it is the next time this will happen across a large portion of the United States like this is 2045. So it is definitely worth it if you can to go see this. And the last bit, there is a lot of science that can be done around the solar eclipse. One is studying the sun itself and that corona, again, that outermost atmosphere. It is a really hot region of the sun, but we don't fully know why it's super hot, and we can't see the lowest part of that corona very well most of the time, even with some of our spacecraft that we have. And so this is a great time to study this region of the sun at the base of the corona. And also right now, the sun is nearing its peak of solar maximum. It's this 11-year cycle with a lot more activity and sunspots happening, solar flares and prominences and solar storms. There's a lot going on, and it was near minimum during the last eclipse, so we're heading towards maximum, which will hopefully give us a lot more to look at. And this is also a great time to study the Earth and the effects of the sun on the Earth, in particular, the uppermost level of the atmosphere called the ionosphere. So I'm happy to talk about that a little bit more in the Q&A if you'd like. But here are some quick resources to put up there, some of my favorite places to go get some information. So thank you.
Fantastic. Thank you. And a reminder to reporters, these slides will be up quickly at the end of the briefing today, so you'll be able to look at these resources and click on them and check them out. Thank you, Dr. Schmoll. And over to you, Dr. Andrew Farnsworth.
Okay, nice to see you all in theory. I'm going to be telling you about what animals do during the solar eclipse, in particular aerial animals like birds, bats, and insects. Focus on birds, though. So just to orient a little bit, thinking about an eclipse, as you heard from Shannon, there's a wonderful opportunity to do some science. And in my case and my colleagues, we're thinking about sensory ecology, so the way that animals perceive their world. It's a wonderful opportunity to do a natural experiment, if you will. We know that light is a very powerful stimulus for many animals. It entrains certain kinds of behaviors. That means it brings them about. It's associated with them. And so what we often see during eclipses from the published accounts is that we may start to see nocturnal behavior. So for example, nighttime behaviors like crickets chirping, bats emerging, to start those sorts of behaviors, and stopping diurnal or daytime behaviors. For example, birds going to roost or day-flying insects landing. So these kinds of patterns, they're important for understanding the ways animals perceive their worlds. And it's not always just about light. As Shannon mentioned, some other things happen too. Temperature decreases, obviously, as the sun's rays are blocked, and wind speeds may often decrease too. So there are a number of different things that may be happening there. Now, one of the interesting things that we're going to be doing, my colleagues and I will be studying this event from a very large scale perspective. We're sort of going to take a unique approach to this, and we're going to use weather radar. Even though weather radar, the network we use in the US to study precipitation and so on, make forecasts, that also happens to be very good at detecting biological activity. And what I mean by biological activity is the animals that are in the atmosphere, those birds, insects, and bats. So we can use weather surveillance radar, the network that spans the entire continent, to look at where animals are in space and time. And the way I like to think about this is a mosaic of 143 radar stations data. And what you see here is meteorology and biology. So the very blocky, irregular patterns, the bright yellows and reds, that's meteorology. That's precipitation, okay? Rain, hail, that sort of thing. Everything else that you see is biology. It's mostly dominated by birds in this case, but also some bats and insects. And what we can do is take away, identify that meteorology, that precipitation, and we're left with the biology. So we can use the radar to really quantify or enumerate what's happening in the atmosphere in terms of that biological activity. How many animals are there up there? So in 2017, we used our weather surveillance radar network to do just that. There were 8 radar stations that were in the path of totality, so 100% obscuration by the moon of the sun. And what we found was a sort of interesting pattern. So what you'll see in these two graphs, on the y-axis, there's that biological activity. Let's think of it as the number of organisms, animals that are in the air. And on the x-axis, you see time. On the left, it happens to be the eclipse, where that vertical bar is when totality occurs. On the right, it's the sunset, when the sunset occurs, comparing the eclipse and the sunset from the perspective of how these animals in the atmosphere perceive light. So as you can see on the left, what we saw during the eclipse in 2017 was a decrease in that biological activity. So a decline in the number of animals flying around. When we compare that to what happens during a typical sunset, you'll notice a very, very different pattern. So what we're seeing here is that the eclipse is strong enough to suppress that daytime diurnal activity of day-flying insects and birds going to roost, but it's not strong enough to initiate the kind of typical nocturnal behaviors we see at sunset, in particular during that August eclipse for birds migrating or bats emerging. So just to summarize, that daytime activity in the atmosphere generally decreased, so the total numbers of animals in the air decreased. We didn't see that sunset-like initiation of nocturnal nighttime activity, like birds didn't take flight to migrate. We did notice that there were some interesting areas, in particular in Kentucky, where there were a slight pulse, a slight increase in nocturnal activities that we think might have been insects. So there's more to learn here, and thankfully, we have 2024. So this year, the eclipse is obviously oriented in a slightly different direction. We're very happy that there are more radars in that path of totality, 13 this time. And what we're interested in is that we can expand some of our knowledge from 2017. We have new sites, more radars to sample with more data. And in 2024, since the eclipse is occurring in April, it's a very opportune time because large numbers of birds are migrating and they're strongly motivated to get to areas where they're going to be breeding, sort of rushing to get there, if you will. So the idea that there may be more motivation for birds to migrate, we're very interested to look at that from the perspective of, are we going to see the initiation of that kind of nocturnal activity because birds are more motivated to migrate during this April eclipse as opposed to the August eclipse, when that motivation is not so strong? Additionally, we're interested in thinking about the northern areas of the United States where the path of totality may actually be in places that have much more winter-like sort of seasonal conditions. And that will be interesting because during those very cold or perhaps snowy conditions, insects and bats will be a non-issue in terms of the biological activity that's in the atmosphere. So we can really focus our attention on what birds are doing, for example. Now, also interesting, of course, some have asked, well, is there any radar station that actually was in both eclipses? Yes, the Paducah, Kentucky weather surveillance radar. So in any kind of scientific experiment, we're always interested in replicating with the same sensor. So that radar happens to be in both the 2017 and 2014 samples. So we're really interested in that. And to close, I'd just like to mention, if you want to follow some of the research updates from the radar perspective, please visit birdcast.info. And also, it's a wonderful opportunity, of course, during this eclipse to observe animals and be outside safely, observing, of course. And if you're interested in doing that and know about birds, you may know about the eBird and Merlin apps where you can enter or record your observations. Very valuable to understand what animals are doing. And just for a little bit of selected additional reference, there have been a number of studies published sort of on smaller scale examinations, what zoo animals do in terms of responding with sort of these typical nocturnal behaviors, sometimes apparent anxiety, what honeybees do, and that they get confused by these changing light levels, and also what a diversity of animals do from a study that was done nearly 90 years ago that sort of took advantage of the same kind of approach of observation to understand how animals behave. Thank you.
Thank you. How interesting, and what a cool thing to be in a zoo at a time like this. I hadn't thought about that. Great. Okay, let's move over to you, Dr. Paul Piff.
Hi, everyone. Just going to share my screen here. Okay. So building off of what Andrew was talking about with regards to what animals do during the eclipse, I'm going to talk about what a particular version of animals, the human species, how they're affected by the eclipse, what are the experiences that are occasioned by something like the eclipse, and what are its effects on social life and social behavior. So I'm a social psychologist, and I'm particularly interested in the experience of awe. And awe can be occasioned by a lot of different things, encounters with art, with music, with spiritual or religious practices. But in the West, we find predominantly awe is brought about due to encounters that one has with nature or powerful natural phenomena such as the eclipse. We define awe very broadly as an emotion or emotional experience that's really arises out of the configuration of two different factors. Awe is brought about by an experience. It could be something you perceive or something you cognize in other ways. But when you experience or perceive something that's so vast, so complicated, so powerful that it makes you feel like you need to reconfigure, readjust, or update your mental schema, your understanding of the world to accommodate the experience. And so awe is kind of described by people often as a mind-blowing experience. And I think people there are just trying to describe that feeling of, wow, I can't really make sense of, at least right now, the thing that I've just experienced. We find, as have others in other psychological laboratories across the globe, that awe has a lot of really interesting effects on people. Awe experiences are described by people as some of the most meaningful in their lives. Those individuals that experience more awe experience improved health outcomes, great or better well-being. They report more humble or somewhat insignificant views of the self. And we find, somewhat interestingly, awe seems to trigger more kind, compassionate, and empathic behavior among people. So to give you a sense of some of the studies that we've run in this area, here's one study where we situated participants in a towering grove of eucalyptus trees, among the tallest and oldest stands of eucalyptus trees in all of North America. And they spent either 60 seconds, again, just 60 seconds looking up at these awe-inspiring tall trees, or with their backs to these trees, looking up at a comparably tall but far less awe-inspiring big building. Once 60 seconds had elapsed, they were approached by our experimenter, who gave them a questionnaire to complete. And in the process of doing so, accidentally, it was actually a staged accident. We practiced this and rehearsed it to make sure it always looked the same, but they accidentally tripped over themselves and dropped a bunch of pens on the forest floor. And what we did was surreptitiously observe and record how many, if any, pens our participants in the study spontaneously bent down and picked up to help this other person out who had ostensibly dropped them on accident. So turning to what we measured on the survey, just a couple of items that reflect psychological entitlement. We asked people to indicate their agreement with statements like, I honestly feel I'm just more deserving than others, or if I were on the Titanic, I would deserve to be on the first lifeboat. We measured how much participants wanted to be paid for their participation in the experiment, and we measured their levels of ethical decision-making by giving them different moral decision-making scenarios and just they would indicate what they would do in these ambiguous situations. What we found, so I want to orient you here, participants in the orange bar represent participants who looked up at trees for, again, just 60 seconds. They bent down and picked up significantly more pens. They reported less entitlement, so they felt less deserving of good things in life relative to others. They wanted to be paid about half as much for their participation in the study, as did participants who looked up at the big building. So maybe awe seems to bring about less materialism, and they made more ethical decisions. Now, in a paper that we recently published just a couple of years ago, we wanted to extend these insights by examining the social and psychological impacts of the 2000 solar eclipse, which, as we've already heard, had a path of totality that reached across North America. And what we did in one of the studies reported in this paper, and we had about 3 million participants in this across the studies in this paper, but we compared residents within the path of totality to residents outside the path of totality, looking at spontaneous shifts in how people talked about themselves and talked about their motivations toward one another surrounding their experience of the eclipse. What we found is that individuals who resided within the path of totality, who experienced the eclipse in its fullness and its, you might say, its full awesomeness or its full power, exhibited more awe. And as a result of that increased awe experience, they became less self-focused, less likely to talk about themselves in individuated me or I-centric ways. They used language that reflected a collective focus, more likely to use collective pronouns like we and us. They expressed more desires for affiliation, to connect and affiliate with others, and they became more pro-social, exhibiting an increased tendency to want to be kind or care for others and to be more sort of oriented to the well-being of the collective. In broad strokes, what we're finding is that experiences that bring about awe, and most predominantly really powerful fleeting experiences like the solar eclipse, seem to attune people and connect us to one another, to connect us to entities that are larger than ourselves. In part, we think that that's how the experience of awe might have evolved. It's the conduit to entities larger than us. It connects us to things bigger than ourselves, motivates us to care for others and the greater good. And I think that speaks to a really positive pro-social impact of experiences of awe and experiences like the solar eclipse. So the question then is, how do we go about cultivating more of it? That's something that we're turning to, looking at in our lab now. I'd be happy to speak to that in the Q&A, but thanks to you all.
That's all so interesting. Obviously, we can't make eclipses happen more often, so it'll be very interesting to hear what alternative methods we might come up with. Thank you all for great start to get us thinking about things. Reporters, a reminder, if you've got questions, please go down to the Q&A box and insert them there. Let us know who you are and what outlet you're with. And meanwhile, just to get things started, I'd like to ask each of you just one question from the moderator first, and maybe that is just to tell us something about what you personally are excited about with this upcoming eclipse, maybe what you'll be doing, but what's turning you on about this particular instance of this awe-inspiring event? Shannon, I'll start with you.
Sure. I think there's a few different things on a very personal level. The last eclipse, I was supposed to see it with my best friend and her family, but she ended up having a baby that day, like born on the eclipse day of the eclipse. So I'm going to be with her and her family this time. And my kids were 4 months old and 4 at the time, so I'm excited to see how they experience it now. And then also I am also a relatively new birder, so I am really excited for listening for the birds and seeing what happens. I'll have my binoculars there for the birds as well as my solar telescope for the sun. So I'm personally very excited for that bit.
That's neat. Let's see, Andrew, what's up?
I'm excited for the bird part too. My plan, I hope, is to go up to northern New York or maybe Vermont to actually see the eclipse. I've never seen one, never seen totality. In 2017, it was only partial, maybe 70%. So I'm very excited to see that. Hopefully, with my kids, it's a good excuse to get out of school for sure. And I plan to certainly be watching what birds are doing, but also what other animals are doing. So I'm really looking forward to that.
Great. Paul.
Yeah, so we're going to be gathering data, as you can imagine. So one of the things I'm going to be doing is monitoring data streams to make sure that everything that we've spent time putting together is going to be coming in okay. Also, we have two very small children at home, which makes travel difficult. So I think thanks to Shannon, we'll probably be outside looking at the sky through Ritz crackers, but we've got crackers at home, so that should be easy enough.
Yeah. Oh, there's got to be a good study to be done about how these things affect kids who maybe have less of an idea of how weird it is. I think everything is kind of weird to a young enough kid. We'll see. Okay, let's get to some questions from reporters, and we'll start here with a question from Abigail Batar from Idea Stream Public Media, which is out in northeastern Ohio. Do you have any recommendations for day of coverage of the eclipse? How best can media outlets cover it as it's happening? Anyone have some ideas there? What does a reporter do to convey what's happening in real time?
Well, I can speak to the animal perspective slightly. So there are a few different opportunities to look at what people are submitting in sort of our citizen science and community science worlds. For example, ebird.org allows you to look at bird observations as pretty much as they come in. And often with those checklists of species that people see are comments and photos of birds and behaviors, videos, things like that. So I'm happy to share some links for how to get into that sort of information. Additionally, from the perspective I was talking about, weather surveillance radar, that is a near real-time experience when you're watching radar. So you can see those sorts of patterns that I was talking about in terms of biology and meteorology and looking at what happens as those radars are monitoring during the eclipse. So that's something you can see in real time from the remote sensing perspective, meaning it's not directly with your eyes out in the field observing. You're seeing what the radar is detecting and then some version of that. So there are a couple of different options there. I think in terms of day of coverage, I know that there will be some updating of websites in terms of thinking about specific sorts of animal behaviors, and I'm happy to highlight that in additional follow-ups if desired.
Great. Any other thoughts?
I think for the astronomy and just observing perspective, people are going to want to know about what the weather's going to be like locally for you and whether or not there will be cloud cover. I know we're anxiously checking, even though we can't know quite yet, but I know some people have plans that if it looks like it's cloudy, they're going to hit the road and try to get to someplace less cloudy and things like that. So I think that'll be of interest to make sure that people can see it.
Great. Okay. Here's a question from freelance reporter Christine Heinrichs. Schools in Lexington, Kentucky will be closed, I'm sure other places as well, out of concern for traffic safety. School bus drivers could be confused. Students walking home from school could be at risk. The reporter is wondering, do you think this is justified? Is there evidence of a safety risk during eclipses?
I mean, I don't think there's a strong safety risk in terms of the sun. Generally, if you look at the sun and it's really bright, it's still going to hurt your eyes and you'll look away. I think those natural instincts take over. But I do think that if you are near the path of totality, there will be a lot more people and there will be a lot more traffic. And so, logistically speaking, it might be easier if people hang out at home. So, I mean, I think it's somewhat hard to say, but I also think, it's also not necessarily a bad idea.
Question from Gabriel Garcia from Wenatchee World. I'm reporting from Washington State, out of the path of totality. What are some talking points to get readers interested, and what should they know? I think each of you might have a different take here, and we've covered some of that, I think, in our comments here. But if you were going to try to convey some point to the general audience about what's going on during this eclipse, do you all want to highlight a couple of things?
Yeah, I can start. So I believe Washington is around 30 to 40% partial eclipse. And so the sun will still be pretty bright, but I do think that the moon going in front of the sun, like even if it's not totality, is a really unique experience to go outside and see that. And so I think kind of focusing on that aspect of it, about this is still a rare opportunity to see how we experience the solar system and how the solar system interacts with ways that make us excited and interested, and that we can see without any real expensive fancy equipment. You do want your eclipse glasses, of course, but those are a couple dollars compared to a several $100 telescope. So I think this is still a unique opportunity to go outside and experience something we won't get to for another 21 years.
Mm-hmm. And Andrew, or even urban birds, in the city, likely to recognize some kind of change?
Oh, yes, animals, as you all probably know, are very perceptive to even small changes in their environment. They're very sensitive to such things. So, just sort of expanding on what Shannon said, the opportunity to go out and observe and to do some of your own science is pretty cool during an eclipse. I mean, obviously, the experience, the astronomical experience, is wonderful from the perspective of just observing what's happening around you and how animals are behaving, humans included, as Paul mentioned. I think it's really an important opportunity. Any chance we have to connect with the world around us, that's a great thing. And further, there are some really simple kinds of questions to which we still really don't necessarily have wonderful answers in terms of, how do animals perceive their world when it comes to light, unusual circumstances, controlling light in particular, that they don't experience. How do they handle that? Yes, we have some published information on it, but the more information we can get, the better, especially information now that's so easy to gather with taking videos, recording audio, taking photographs, to document what you see around you. These observations are kind of the currency of how we do science. So I think it's a really wonderful chance to just get out, even if you're not at 100%, if you're at 30% or 20%, it's all, both very cool and really valuable information.
Paul, people watching?
Yeah, always. I guess I would add that, the path of totality for good reason, or places within the path of totality attract a lot of attention. But that's not to say that a partial eclipse isn't awesome. There are lots of ways to experience the eclipse. And, I think my first eclipse was a partial eclipse, and I just took some time to take it in. And, there's a lot of social science on the kind of decentering that that experience can have. It kind of decenters the self. It reminds you of the bigger things that we're a part of, which I think is a very profound experience for humans that we all kind of long for without knowing it. And the kind of awe, or whatever word you would use to describe it, but that feeling that you get from experiencing something like that, even if it's not the full eclipse, is ineffable. It's long lasting. It has important individual benefits and I think social benefits. And it's one that you'll remember for a long time. So just taking a little bit of extra time out of your day to have that experience, I think, will pay back in dividends.
Great. Freelance reporter Mary Miller is going to have the good fortune of being in Mazatlan during the eclipse and is asking if there have been any studies on marine species, curious whether, for example, plankton might migrate down in response to decreased light. Anyone see any data on that?
Yeah, that's a great question. So yes, it does hold true for marine animals. There is not a huge amount of information, and hopefully this might inspire people to get out and collect it. But fish and other aquatic organisms, whether fully aquatic or partially aquatic, like amphibians, do start to initiate nocturnal kinds of behaviors. Yes, certain kinds of plankton, zooplankton in particular, starting to rise to the surface and then descending as the light starts to return in the area where light sort of proceeds into the water. Um, Various kinds of things like that are what with again these behaviors of starting to initiate the nighttime type behaviors as that light darkens. That absolutely is something we see in the oceans too. So that's certainly an expectation, and so too, if you are by the coast, seeing kinds of how fish are behaving, starting to see some of those fish that typically come out at night and get closer to the surface, you'll likely start to see patterns like that. Maybe changes in the way fish school, certainly the way that some animals, in particular birds on shorelines, may start to gather into groups as if they're going to roost. That's the sort of thing to look for in places like that, especially in Mazatlan.
Okay. Question from Joshua Murdoch from the Missoulian and Lee Enterprises, who covered the 2017 eclipse in Idaho for local paper there, found that a lot of the warnings about where the crowds were going to be and the safety hazards were not accurate. Is there a way or a resource to see where people are going and not going in somewhat real time, I guess? Shannon, you were stuck in traffic all those hours. Is there some resource you should have been looking at?
I don't know. I don't think I found it. Yeah, I don't know on that one.
Yeah, we need some real-time radar that's doing traffic reporting. It seems like Waze or something ought to be telling people where the traffic is.
I was going to say Waze is probably probably as good as any, I bet.
Yeah.
Yeah, I do know that there have been studies, I can't remember the details on them, but there are studies out there about the traffic during the last eclipse that maybe that will offer some insight and on ideas on what might happen this time, but I don't know. I don't know what to expect yet.
Question for Dr. Piff from Lindsay Wallace, freelance reporter. Is there any sense of how long the positive psychological effects of awe-inspiring experiences tend to last, or any habits that seem to prolong those effects?
That's a great question. It's I don't want to give you a long answer, but there is a long answer. In the eclipse paper that we published last year, we followed people for 6 weeks after the eclipse, and levels of so the patterns that we document seem to kind of return to baseline within that 6 week post-eclipse window. So that's not to say that the effects are as fleeting as the eclipse itself, but they seem to kind of go back to people's normal sort of default modes. We've done some work where we looked at more repeated experiences. So what do you do if someone does like a daily awe practice? They get better at experiencing awe and experience more sort of long-lasting behavioral change. So I'm happy to talk to you about that, but basically one experience isn't enough. But if you orient yourself, learn to attend to the world in ways that bring about awe, which I think is a simple practice that people can do, then you'll experience more of it, even in mundane or quotidian ways. And because of those more frequent experiences, you'll experience a lot of its more long-lasting benefits.
Fascinating. Freelance reporter Nicholas Jervis is writing in to say that subjectively, it appears to me that the quality and perhaps even the dominant wavelengths of light changes throughout a solar eclipse. Is this correct? And have any of you examined this phenomena with respect to your field of interest? Do the wavelengths matter there? We didn't get a physicist on this panel.
I can, yeah, from the ecological perspective, I can jump in. I'm definitely not a physicist, but I can tell you that yes, that idea of sort of how animals respond to different wavelengths, and in particular, different intensity of lights, both of those things in conjunction. That's still a very active area of research, in particular when it comes to birds. But it has not been something that we've investigated, the royal we, so to speak, when it comes to eclipses very much. I don't think there are many, perhaps any studies out there from the perspective of birds that have looked at that, but it's an interesting idea and certainly something that we can put on our collective radar, so to speak, no pun intended, for this kind of an event, because intensity and wavelength are really important, both for orientation, for navigation, for various ways that birds perceive their environment, and other animals too. It's a good question. Thank you.
Insects as well, so that could be interesting. Here's an interesting question for you, Shannon, from Issam Ahmed from Agence France Presse. What are the major outstanding astronomy questions when it comes to understanding things about the corona and the ionosphere, et cetera? Can you mention a couple of those?
Yeah, so I think so for the corona, that is something that we do study all the time. We have spacecraft that can artificially block out the main disk of light from the sun so that we can study that corona. It's called a coronagraph. The thing is that that doesn't get right down to the edge of the disk. And so during the solar eclipse, with the way that the moon covers the sun, we can see that bottommost part of the corona where a lot of that activity and flares are really happening, where that corona meets the surface of the sun and how they interact. And so this is the opportunity to help us really understand that lowermost part of the corona. And then again, because we've got we're nearing solar maximum, we'll also be able to see some prominences and flares coming off during the eclipse and get a nice view of that. Hopefully there'll be something exciting happening, might not, and we have to get lucky there. So that's why studying the corona is still really useful during an eclipse. For the ionosphere, that is the uppermost layer of the Earth's atmosphere, sort of as we go into outer space, so to speak. And so the side of the atmosphere that's facing the sun's energy is intense enough to strip the electrons off of the particles. So it ionizes, and we are left with charged particles in the upper atmosphere. And so then as the Earth rotates, those particles will then sort of recombine and go back to a more neutral state. And then as continue to rotate, we end up with more charged particles again. This is also can affect a lot of the satellites that are up in orbit and their communications with one another. And there's also all these other things that seem to impact it related to the Earth and the sun and space weather and Earth's weather and so on. There's a lot that can impact that. So having the eclipse where it's a more localized sunset, essentially, in a way, that's a much shorter lived thing. We can get, again, the royal we here, we can get a much more clearer picture on what exactly is going to be affecting that ionosphere in different ways to help us better predict those changes.
Yeah, again, an experiment that nature is providing for us. It's interesting. Here's a question for you, Dr. Piff, from Nick Swartzell from an NPR member station, WVXU in Cincinnati. Are there historical records or cultural traditions that reflect the senses of awe that eclipses have inspired in past societies? A little bit of an anthropological take here.
Yeah, it's a great question. I think the time is nigh for a kind of a cultural history of eclipses, their social impact across history. So I'm not a historian, and I'm not a great repository of this. I know that when we went looking, there are some historical accounts. For instance, Herodotus, the ancient Greek historian, talked about an eclipse having ended a 6-year war between the Medes and the Lydians. They both, like, this may be apocryphal, but it's reported all over the place, dropped their weapons and were absolutely adamant about coming to some kind of truce. Maybe you could say that experience of wonder sort of eclipsed whatever human factors might have been giving rise to the antagonism they were experiencing. And then there's kind of spotted accounts of, for instance, eclipses or an eclipse having inspired the works of Shakespeare and King Lear. ancient Hawaiian culture, the emergence of new scientific fields of study have been tied to certain eclipse events. At the very least, you could say that to the extent that something like the eclipse, which is so wondrous and can be so puzzling to so many people, especially prior to an understanding of what gives rise to an eclipse, it makes you curious about the world. It makes you curious about new ways of gathering information and assimilating the experience. And so it certainly seems to fuel a creative impulse within our species.
That's really interesting.
May I add something?
Mm-hmm.
So there is also a really great resource from the Astronomy Society of the Pacific that gathered together a lot of ways of knowing around eclipses from around the world. So I would also encourage checking out the resources from them.
Neat. I think this is for you, Shannon, from Sandra Brogan, Local News Live in DC. During totality, is it safe to view it without eclipse glasses?
Yes, and in fact, you have to take off your eclipse glasses in order to see totality. So the corona, even though it is really, really bright or really, really hot, it's not particularly bright. So you do need to take your glasses off to see that. But any other time, at any point, if that main disk of sunlight again is visible in any way, you want to make sure you have those on. But outside of that, during totality, take them off.
Okay, great. And one other question that I think might be yours. This is from Dan Scoff from KNWA and Fox 24 in Northwest Arkansas. Is the double diamond ring the same thing as Bailey's beads? You'll have to define those for us. And what are your thoughts about the possibility of seeing the double diamond ring near the center of totality? What is that?
So the diamond ring effect is something that as the moon is going across the sun from our perspective, we'll see it the sun's disk as a crescent that gets smaller and smaller. But as we get really, really close to the very edge, we'll just sort of see this little bright, brilliant ball of light that then disappears. And so that's the diamond ring effect. And then Bailey's beads are sort of related in that it's sort of more an effect right before that happens, where you have like almost a string of beads of these effects going on. I don't know much about the double diamond ring, so I don't know if I can really speak to that. But yeah, the diamond ring effect is your sign that totality is about to happen, and then you can take off your glasses. So.
All right. I'm going to try to squeeze a few more questions in here, our last 10 to 15 minutes, from a few reporters. Actually, we've got variants of this question. Barbara O'Brien at Buffalo News and freelancers Monica Makel and Laura Wakowitz among them. What will be the effects of cloudy weather during the eclipse in each of your areas of research, besides the enormous disappointment that's going to be experienced by everyone who's hanging out in those cloudy areas? Is the danger to the eyes the same when it's cloudy? Will you still see the effects in animals, but to a lesser degree? Why don't we just try a few of you here? Andrew, anything about birds, and will that, do we know what impact the clouds will have?
Yeah, so even when there is a really intense cloud cover that's not in an eclipse, like for example, at the end of the day, maybe it makes sunset seem a little bit earlier. Animals respond to that. So actually, cloud cover likely will initiate probably more extreme behaviors in animals. So if you're in the path of totality and you have cloud cover, that's going to make for extremely dark conditions on the ground, or at least below the clouds. So I would expect, we don't know this for certain, but I would at least hypothesize that animals will respond more extremely to that. So we'd see the initiation of more of these nighttime type behaviors and the suppression of more of the daytime type behaviors. We'll be able to look at that from the radar perspective if we have sites that have cloud cover where the radars are sampling. So we should have a swath of, Texas to in the US anyway, Texas to Maine. We should have good opportunity to cover that. Sorry for the people that are in, the cloudy places looking, but so we'll be able to answer that, but that's what I would expect anyway.
Any other comments on, are we going to get less awe with more clouds, more awe with more clouds?
We don't know. I would only speculate that to the extent this is just intuition. So don't quote me as science, but if people have taken the time out of their day and in some cases put a lot of costs forward to have this experience, and then it is engulfed by weather, it's going to be disappointing. I would say the focus is then shifted toward, how do we not get to have, so less awe, probably less of the impact of a solar eclipse. We, unlike birds.
Right. Okay. There was a follow-up question for you, Paul, I think from Amanda Goki from the Boston Globe, asking about your all research and whether you're planning to continue or expand this in the coming eclipse, what questions you have that you'd like to get answers to.
Yeah, it's a great question. We're looking at two things that might seem top. We're going to do a better job of capturing the ephemeral or long-lasting nature of the psychological impact of having experienced the eclipse. So we're tracking people. How did they experience the eclipse? Where were they? How do they talk about it? How do they share it with others? And then how long do those emotions, those experiences, and their impact last? And in this study, we're also really interested in one kind of social connection across the political spectrum. And so we're looking at whether the eclipse can, at a time like now, decrease political polarization. So we're tracking people on both ends of the political aisle to see what an experience of being connected to something larger than you, being reminded of your relative insignificance, can do to how you make sense of the world, the political world, and the matters therein.
That's super interesting. There are a couple of questions here from Lucy Auborg from Agence France Presse. For you, Andrew, asking how quickly animals react to the changes that you've described and how quickly they'll go back to normal. And I think, yeah, on a deeper level, why it's useful to know how birds are reacting. Is there something we're learning other than the fact that they are reacting this way? Does it tell us something about them?
Yeah, that's a great question. So in terms of the response time, from one of those graphs that I showed, really we're talking about, I mean, during the period of totality that's, or during the eclipse that's going to last, some probably an hour and a half, 2 hours, whatever the total time is from when the moon starts crossing over the sun until when it leaves. It does not take much time, on the order of certainly minutes, to start seeing animals behave in different ways. So birds in particular respond very quickly to changing light levels, and insects respond very quickly to changing temperature and obviously changing wind conditions. So in some cases, it might be almost instantaneous, but certainly over the course of minutes, as soon as it begins and the light starts to dim, you're going to see animals start behaving in interesting ways, whether it's going to suppress the daytime activities or initiate the nighttime ones. You're going to see that quickly. And then in terms of the response back, it's equally fast. So really, from that period of totality, of total darkness, there is a rapid shift in that 2 to 4 minute period of what animals are doing, starting to respond to, oh, it's getting dark, suddenly it's getting brighter. That happens quickly. So that's sort of the time frame we're talking about. From the perspective of why is it important, I think it's really critical to remember that the same way that humans often think about the ways that they perceive the world, right, and what our perception, what our senses are telling us about it, we still don't know very much about the way that other animals do that. It's one thing for us to verbalize and to discuss and communicate about it. Obviously, presumably animals are doing the same thing, but they're certainly experiencing their world. So thinking about sensory ecology, even if it's something as rapid as an eclipse and as unexpected from the animal's perspective, that may not have any memory of the past eclipse at all. Either because they were not alive, these animals are mostly short-lived when it comes to insects in particular. It's a really interesting opportunity to think about that sensory perspective. And I think even more broadly to think about, we do know a lot about, for example, how light influences the way and impacts the way animals behave, many different ones in different ways. But it's very rare that we get to have a study where the natural source of light is basically extinguished to the point that it begets these kinds of nighttime behaviors or stopping the daytime behaviors. So it's a really unique opportunity to think about that, both at the broad scale of how animals perceive, but also at that small scale of what do they do in that instant when the light levels are declining, then immediately start increasing again in this period where there should just be light all the time. Really interesting opportunity to think about that.
Very cool to think about whether animals are feeling awe in that moment and whether they would show more pro-social behavior. Maybe that's an experiment for next time. We're almost out of time, and I want to go round robin here and get some final comments from each of our speakers today, take-home message from each of them, which are often some of the pithiest things for reporters to walk away with. But I want to remind reporters first, as you get ready to sign off today, that as you log off, you will be presented with a short survey, just 3 questions, maybe 4. It's very quick. It's very helpful to us as we plan these briefings so we can bring you what you need most to help you in your reporting and to help you get science into your reporting. So please take that half a minute to answer the survey. And now I'd like to ask each of our panelists just one last question, which is just a take-home message, something that you want to leave reporters with. If there's one idea you want them to walk away with as they start thinking about their stories and what they can say in them, what would you like to convey? Shannon, I'll start with you.
I think that the experience of seeing an eclipse is really hard to describe. I mean, I think you've heard sort of the science behind it and how it can inspire awe, but actually getting to be able to see and feel that awe is a really unique experience. And so I hope that people are excited for it and think of this as a really wonderful opportunity to again see the universe in action in a way that we can see from our own homes, really.
Great. Andrew.
I will absolutely echo that. And I'll also say that I think it's a really amazing opportunity to do 2 different kinds of observations sort of to experience. The second of which I think is more important. I'll tell you. The first is from the technological perspective, obviously studying the way we do with radar, but also some of the technology we have to document what's happening, photographs, audio, video, etc. I think that's a really unique opportunity to save this and kind of be able to share amongst ourselves information that is happening as it's happening or close to it. So from the technological side, there's this great connection that we can all have. I think more important than that, though, is that connection to being, in particular, if you're out in whether in totality or whether just on the fringe or whether just looking from really right on the edge of where the eclipse is visible. I think being out is really important and being connected to the world around you and actually like being careful not to just be on your smartphone all the time or, being stuck in technology, but actually being in the experience. I think that's very important, whether it's observing animals or just in feeling the sense of awe. I think that's critical.
Great. And Paul.
And I don't think I need to add, but I would just say that guided by what Shannon and Andrew just said, to the extent that you can encourage people to go out and create a moment around the eclipse in whatever way they can, to have an experience that will stick with them, that I think you could remind readers will be interesting, certainly stimulating in certain ways, but also be beneficial, not only for them, but the science says for those that they're connected to and for the world around them. So lots of good reasons to go out and take the time to do it.
Can't think of a time when we could use it more. So thanks for that. I hope everyone will get out and have that experience together. I want to thank our 3 panelists today for really fascinating respective takes on what's going to be happening cosmically on the 8th. Thank you all for taking the time, for sharing your scientific knowledge and your insights. Thanks, reporters, for covering this event and enriching it with this kind of information. And we look forward to seeing you at our next SciLine media briefing. So long.